So you're gonna be, do you think you're gonna finish by this week? No.
All right, let's get started. So today we're just talking some more about trig substitutions. And maybe there's more questions, maybe there's not very many. Either way is fine. It's everybody got the weekend at least to work on it and see if there were any additional questions. So if you do have any more questions, I am happy to answer them now. Yes.
So for the problem of 24.
Yes.
When we get the final answer and we have to plug in the u's back, but the u's are like sine inverse of x over 3, how do we how to simplify it?
Okay, how do you get it back?
Yes.
Yes, okay. Do you want to do that one or?
Yeah.
Okay, let's do 24. We've got integral of 9 minus x squared, square rooted, divided by x squared dx. Okay, so first question, what is the form that we're looking at with 9 minus x squared? What's the appropriate thing to substitute in a sine, a secant, or a tangent? A sine. So it's 1 minus sine squared of x equals cosine squared of x. So our substitution should be x is equal to, we know that sine of theta is going to be a part of it. And then what goes in front of the sine? Yeah, we need a 3 so that when we square it, we get a 9. So we need 3. Okay, so dx in this case would be 3 cosine theta d theta. Okay, so let's rewrite this. We have the integral of, on top I get square root of 9 minus, and then I square x. When I square this, I get 9 sine squared theta. And then on bottom, I have x squared, which is 9 sine squared theta. And then I have dx, but dx is all of this stuff. So I have an additional 3 cosine theta d theta. Okay, so a couple things here. First of all, I could factor out the 9, right? And in fact, I could, not only could I factor it out, I could bring it outside of the square root. And if I bring it outside of the square root, what is it? A 3. So I get a 3 times 3 on top, and I get a 9 on the bottom. So when that comes out, it's just a 9 over 9. So let's rewrite this. Maybe I'll go this way. So I factor out the 3 here, and that's 3 times 3 is 9. And this 9 can come out as 9 integral of the square root of 1 minus sine squared theta. The 3 has gone out. I still have times cosine of theta divided by sine squared of theta d theta. Okay, so the 9's cancel. 1 minus sine squared of theta is cosine squared of theta. So I can write this as integral square root cosine squared of theta times cosine of theta divided by sine squared of theta d theta, which is integral of cosine squared of theta over sine squared of theta d theta. But what's cosine of theta divided by sine of theta? Yeah, cotangent of theta. So this is just the antiderivative of cotangent squared theta d theta. Now, whose derivative is cotangent squared of theta? Anybody? Or do we need to do some work first? We may need to do some work first, right? Because we know that 1 plus cotangent squared of theta is cosecant squared of theta. So cotangent squared of theta is cosecant squared theta minus 1. So I can rewrite, let's do it right up here. So this is integral of 1 minus, I'm sorry, it's not right. So cotangent squared of theta would be cosecant squared of theta minus 1 d theta, which is otherwise known as, now I can take an antiderivative. Antiderivative of cosecant squared of theta would be what? Negative what? Yeah, negative cotangent of theta. Does that sound right? Negative cotangent theta. Antiderivative of negative 1 is minus theta plus c. And this is where you're probably asking the question, right? Is we have thetas. We don't want thetas. We want x's, correct? Okay. So this is where we use a reference triangle. And what I mean by that is let's go all the way back to our substitution. And we've got the following. X equals 3 plus sine of theta. We could also write that as sine theta is x over 3, correct? Now if we look at a right triangle, and we call one of the angles, let's call this one theta. Sine of theta is, does anyone remember there's opposite, adjacent, hypotenuse? What is sine? It's the opposite over the hypotenuse. So it's the opposite over the hypotenuse. So the opposite is x. The hypotenuse is 3. And then my question is, what's that? So we have to use the quadratic equation to figure out what this third side is. So we get that, if I called this, just for now, let's call this y. And we get that y squared plus x squared is equal to 3 squared, right? Or that if I'm solving for y, I get y squared equals 9 minus x squared, and y is equal to the square root of 9 minus x squared. I guess it's positive. This is the square root 9 minus x squared. Now, that's interesting. Why? Because at the very beginning, I was trying to get rid of something. 9 square root of 9 minus x squared. And it just so happens that that shows up again. That's very common. That the third side of your triangle is going to be the thing that you originally substituted for. So that's very common. It's not every time. So don't just think that's just how it always works. Still do the work and figure it out. But when you come up with exactly what you substituted for, you should be like, yeah, that makes sense. Okay. Now what? Well, now I can look at, if this is theta, I know the sides of the triangle. And I want to know, okay, what's cotangent of theta? Well, cotangent is, what's tangent? It's the opposite over the adjacent, right? Opposite over adjacent. So the reciprocal of that cotangent is the adjacent over the opposite. Okay, so this would be negative the adjacent side over the opposite side. The adjacent is square root of 9 minus x squared. The opposite is x. So it's the square root 9 minus x squared over x. So the adjacent over the opposite. Minus theta. Well, if sine of theta equals x over 3, then what is theta? Sine inverse of x over 3, right? So we could say theta is sine inverse of x over 3 plus c. And that's it. Makes sense. So oftentimes in these problems, you're going to have to use the reference triangle to kind of get back. So you have to figure out, okay, what are we dealing with? Since in this case it was sine, you've got opposite over hypotenuse. Fill those in, find the third side, and then use those 3 sides to get whatever you need back there with trig functions. And you just use, well, how does that work with theta, like a tangent or whatever? Yeah. Sound good? Other questions? Yes. 26. Sure. So one of the beautiful things about having a definite integral opposed to an indefinite integral, which is what we just had, the definite integral, you never have to use the reference triangle because you don't have to go back, right? In the indefinite integral, like we just did, you got to get back to your original variable. But in the indefinite integral, in the definite integral, which is what we're about to have, we don't have to use a reference triangle because we don't have to get back to the x's. We can just switch variables and stay there. Okay. Okay, so 26 is the integral from square root of 2 to 2 of square root of x squared minus 1 square root x squared minus 1 divided by x dx. Okay, first question, what is the form? So we've got something squared minus 1. What is that like? What's that? Exactly. So tangent squared theta equals secant squared theta minus 1, right? So secant is the guy that's going to help me in this case. Yeah, that's exactly right. So x is equal to, we know it has a secant of theta. Anything else? No, it already has a 1 here. So if I square this, it's going to be exactly what I want. So this is right. And so now we just need to know what's dx. And the derivative of secant of theta is secant theta tangent theta d theta. Okay, so let's make a substitution. So we have integral of square root. Plug in for x, and I get secant square root of theta minus 1, which is great. On the bottom, I have an x, which is a secant theta. Then we need to multiply by dx, which is secant theta, tangent theta, d theta. And we should also change our limits of integration if we can. So if x is square root of 2, what is theta? Okay, if you want to think about that this way, this is 1 over cosine of theta, right? So 1 over cosine of theta, well then cosine would be like square root of 2 over 2. Where's cosine equal to square root of 2 over 2? Pi over 4. So that means that secant of pi over 4 would be root 2. Yeah, sure. So this is the way that I think it through in my own head when I'm trying to do these. So I know that root 2 is equal to secant of theta, correct? So another way for me to think about that is root 2 is equal to 1 over cosine of theta, because I like cosines better, right? Now what I do is I say, okay, That's more difficult. So but I could kind of cross multiply if you'd like to cross multiply. What I like to do is I just say, just flip both sides. So I say, if I reciprocate this, I get that cosine of theta needs to be equal to 1 over square root of 2. But that's also root 2 over 2. So cosine of theta needs to be root 2 over 2. That would happen at pi over 4. So that gets it for me. It's like, okay, so theta needs to be pi over 4. I can put that in here. Let's do the exact same thing, except now secant of theta needs to be 2. So if secant of theta is 2, then 1 over cosine of theta is 2. Now we could reciprocate. And we could say that cosine of theta is 1 over 2. And now it's like, oh, okay, good. What angles cosine is a half? What is that? Pi over 3, right? Pi over 3. So this is going from pi over 4 to pi over 3, and now we never have to look back and worry about x's again, which is nice. Okay, also we have a secant of theta on top, a secant of theta on bottom, so we can cancel the secant of thetas and move on. All right. So this is going to be integral pi over 3 on top, pi over 4 on the bottom. That's kind of weird. Okay, and then we have secant squared theta minus 1, which is tan squared of theta square rooted times tan theta divided by nothing, right? 1 d theta. So this is just equal to integral pi over 4 pi over 3 of, once I square root that tangent squared, it's just tangent, so I just get tangent theta squared d theta. And now I need to use the exact same trick that I did last time, where I changed the tangents to secants. So 1 plus tangent squared theta is secant squared theta. So tangent squared of theta is secant squared theta minus 1. So I could rewrite as integral pi over 4 to pi over 3 of secant squared of theta minus 1 d theta. And now I can take an antiderivative. So this is just equal to tan theta minus theta evaluated from pi over 4 to pi over 3. Which is, if I plug in pi over 3, I get tan of pi over 3. We can think about that in just a second. Minus pi over 3 minus tan of pi over 4 minus pi over 4. Okay. So what is everything here? First of all, what's tangent of pi over 3? That's sine of pi over 3 divided by cosine of pi over 3. What's sine of pi over 3? Yeah, root 3 over 2. And then cosine of pi over 3 is a half, right? So it's root 3 over 2 over a half, which is root 3. But we'll write it in a second. Minus pi over 3 minus tangent of pi over 4. Tangent of pi over 4 is what? 1. So it's minus 1 minus pi over 4. Now let's combine things. This is just root 3. So I've got square root 3 minus 1 minus pi over 3 plus pi over 4. And I don't really know if we're going to get much better than that. One thing I would do personally is say, okay, is this actually like a positive number? Because it'd be really nice if it were. Correct? I don't think that this thing is ever negative that I'm looking at. So it's not going to be a negative number. But square root of 3 is bigger than 1. So this number is positive. But what is this number? This is negative, right? So I might just plug that into my calculator real quick and just make sure that that actually is a positive number. And if it is, then I feel pretty good about it. It is? Okay. Then I feel pretty good. Okay. Other questions? Yeah. 18. Sure. Any questions about this one before I do 18? Okay. Somebody wrote to me. Let's see. Yeah. Okay, so number 18. We have integral dx divided by 1 plus x squared excuse me, to the 3 over 2. And that's it. Okay. Okay, first question we always ask on one of these problems is what's the form? So what do I need to use? Tangent, sine, secant, which one works? Yeah, does everybody agree tangent? Yeah, because 1 plus tangent squared theta equals secant squared theta. So this is in the form 1 plus a tangent. So we let x be equal to tangent of theta, and I don't need anything else because it's already a 1 here. So dx is going to be equal to secant squared theta d theta. Now we're ready to make a substitution. This is integral. The dx is on top, so I get secant squared theta d theta on top. On the bottom, I get 1 plus x squared, which is tan squared theta. All of that raised to the 3 over 2. Okay. Now I can make a substitution for 1 plus tangent squared theta. I get integral of secant squared theta divided by 1 plus tangent squared theta is secant squared theta to the 3 over 2. That's it. Sometimes, like, it can be frustrating doing these problems, not so much because the problem is really, really difficult, but because it's like there's a great, great temptation to skip steps in these problems. Because I'm kind of like, hey, I'm pretty good at this. And so like what I'm going to do is I realize that this is secant squared theta, and then it's to the 3/2 power. So it's secant cubed, and it's right, but it's so easy to make a mistake. So what I would really recommend to you is, and I still do it, and the reason I still do it is because I make mistakes if I don't do it, is take your time. Like, it's okay to take the extra 5 seconds that it takes to write out that in-between step, just to make sure that you're doing it right. It is easy to mess up when you're like jumping and you miss things. So just make sure you're doing it. Usually in one step, just do one thing. Don't do 2 or 3. Because if I was really being clever here, right, I'd be like, this is sine squared to the 3/2 is sine cubed. Oh, it's a sine squared over a sine cubed. So it's just sine of theta, and write sine of theta. Well, it's not sine of theta. It's 1 over sine of theta. And it's just easy to make the mistake, right? So I'm just giving a warning that skipping steps can mess you up for sure. Okay, let's keep going, d theta. So we have integral of secant squared theta is on top. On bottom, I have secant squared theta to the 3/2. So I multiply the powers, which would give me 6/2 or secant cubed theta d theta. Now some things cancel, and I'm just left with 1 over secant theta d theta, otherwise known as integral of cosine theta d theta. It's pretty good. I can take an antiderivative, and I just get sine of theta plus c. All right, but I didn't start with a sine of theta. I started with a tangent of theta. So I need to use a reference triangle to get back, correct? So let's do that. So here's my right triangle. Here's my theta right here. And I've got tangent of theta. If you like, I'll write it again right over here. Tangent of theta is x divided by 1. Now tangent, remember our little opposite adjacent hypotenuse. What's tangent? Opposite over adjacent. That's right. So we've got the opposite side here. We've got the adjacent side here. So the opposite side is x. The adjacent side is 1. And now the question is, what's the hypotenuse? So we can say that, okay, x squared plus 1 squared, which is 1, is equal to the hypotenuse squared. And then I just need to figure out, well, then what's the hypotenuse? Square root both sides, and I get the square root of x squared plus 1 is h. Now, is that what I started with over here that I was substituting for? Kind of. It was that cubed. So that's where I'm saying, don't just say, well, whatever's here, that's what goes here. Not quite, but so be careful. But this is a square root x squared plus 1. Now that I know that, I come back to where I was at, which was right here. So I have, oh, no, it isn't. It's right here. And I have sine of theta. So what is sine of theta? Sine is what? Opposite over the hypotenuse. So what is the opposite side of this triangle? X, correct? So it's x over the hypotenuse. And the hypotenuse of this triangle is square root of x squared plus 1. So square root x squared plus 1 plus c. And that's it. Sound good? Now, if I got this, like if I were taking an exam or something, and I got this answer, there would be a great temptation for me. And that would be, if I really want to know, did I get it right? I could just take the derivative, right? It's just a quotient rule problem, right? So I could just use the quotient rule on this and just make sure that I get what I had up there. Okay, so that's a good strategy sometimes on exams but sometimes you get something that's so disgusting here that you're like, yeah, forget it. I'm just going to trust myself. But in this case, I think this is easy enough to take the derivative of that I might just take the derivative real fast to make sure that I get what I started with. Okay. Anything else? I feel like we've covered a fair amount of these problems, so that should put you in pretty good shape to do these things. So, and if you need a review, got all the problems online, and then all the problems that we've done the last 2 days are online too. So that should give you what you need. Let me see, somebody wrote something. 25. Let's see. Yeah, why not? I'll do 25 and then we'll be done. Okay, so 25. You got integral of square root 9 minus x squared over x dx. Square root 9 minus x squared over x dx. Okay, so what's the form? Tangent, sine, or secant? Sine, that's right. So the one to remember is tangent squared theta equals 1 minus sine squared theta. So we're in a 1 minus something squared, so it's sine. So we take x is equal to sine theta, and then do we need anything else? And what do we need? We need a 3, so that when it's squared, I get a 9 to match the 9 I already have. So I need a 3. So now I get dx is equal to 3 cosine theta d theta. Now I can make my substitution, and I get integral of the square root 9 minus 9 sine squared theta divided by x, which is 3 sine theta. And on top, I still have dx, so I get times 3 cosine theta d theta. Okay, let me move over here so I have enough room. All right, so now we can simplify a little more. And we get, I could pull the 9 out of both of these, and it will leave me a 1. And then I could pull that 9 even out of the square root, and I get a 3, correct? So I'll get a 3 from these guys. I'll get a 3 here, so I get 9 on top, 3 on the bottom. So I get a 9 on the top here. I get a 3 on the bottom here. And then what's left over is square root 1 minus sine theta squared. Oops. 1 minus sine squared theta times cosine theta divided by sine of theta d theta. All right. This can be simplified. So this is equal to 9 divided by 3. It's just 3 integral of square root of cosine squared theta times cosine of theta divided by sine of theta d theta, which is 3 integral. We get the square root of cosine squared is just cosine times cosine is cosine squared theta divided by sine of theta d theta. Okay, which is equal to 3. And now we have to be a little bit clever here, realizing that cosine divided by sine is what? Cotangent. So this is cotangent. Maybe I don't like it. Let's see. It is cotangent theta times cosine of theta. I don't know if I'm in love with that. Okay, so let's not do it. Let's change the cosine squared of theta into, let's see, do I like that? Okay, so I've got an odd number of these, correct? do I like the best here? So I could change these into sines. So I could write this as 1 minus sine squared of theta. Then I get 1 over sine of theta, which is a cosecant of theta. Do I like it? It's okay. I can do an antiderivative of cosecant of theta. And then I'd get a sines of theta over a sine. Yeah, I guess that works. Okay. It's not the prettiest thing I've ever done, but it works. Okay, so this is 1 minus sine squared theta divided by sine of theta d theta, which is 3 integral of 1 over sine squared of theta is otherwise known as cosecant of theta. And minus sine squared over sine is just minus sine of theta d theta, which is equal to 3 times. What's the antiderivative of cosecant of theta? This is one of those kind of funky ones, right? With a natural log. Does anybody remember off the top of their head? Yeah, first of all, it's negative, right? So it's negative ln absolute value of what? Yep, cosecant theta plus cotangent theta. That's right. And then the antiderivative of negative sine of theta is what? Positive cosine of theta. Plus c. Okay, and now we just need to use the reference triangle to get it back to x's again. What did I start with? I started with x is equal to 3 sine of theta. That means that sine of theta is equal to x divided by 3. Draw our triangle. Sine is the opposite over the hypotenuse. So the opposite side is x. The hypotenuse is 3. And that means that the other side, you can't get good at these things, is square root of 9 minus x squared, which is that what we kind of substituted for to begin with? Yeah, it's exactly right. Okay, and now we can just fill in the blank, so to speak. So this is equal to 3 times negative ln, absolute value, cosecant of theta. Okay, that's 1 over sine of theta. Sine is opposite over hypotenuse. So this guy must be hypotenuse over opposite. Hypotenuse over opposite. Hypotenuse is 3. Opposite is x. So it's 3 over x plus cotangent of theta. Cotangent, tangent is opposite over adjacent. So cotangent is adjacent over opposite. So adjacent is right here, the square root. Opposite is x. So it's adjacent square root 9 minus x squared over opposite is x. Okay, close bracket, plus cosine of theta. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse plus c. I need to close my parentheses. There we go. This is one where I would not take the derivative and try to get back to the original. It makes me want to cry a little bit, but it could be done. Any questions? Yeah.
Did you sum that?
Which one? This one?
Yeah.
Okay. Okay, what would you want to use sub for? So if we substitute for sine, the derivative is cosine of theta d theta, but I have 2 cosines, so it's not so good on sine. If I use cosine, then the derivative is sine theta d theta, but I actually have a 1 over sine theta d theta. So that's not so good either. I'm not saying that it cannot be done. I'm just saying that it's a little bit ugly. So I think you actually could do it. What do you think for a second? Yeah, you could. It's ugly. You could. But you'd have to like factor out a sine, which means there'd be, so what I would do if I wanted to use a U substitution is I'd say, let's write this as sine of theta here on top and then square the bottom. Now change the bottom into 1 minus cosine squared of theta and then do a U substitution for cosine of theta. That would work. I don't know if that's better, but it does work. Okay. Yeah, that would do it. Anything else? Let's see what we got here. Okay, cool. That's it for today then. So Wednesday we will cover the next section, which I believe is, let me just make sure, yeah, on partial fractions. So make sure to watch the videos before then and come to class having started the homework so you have some good questions to ask. Have a good day. I'll see you Wednesday. Sure.
So I know I'm wrong when I approach this way, but I don't know why I'm wrong.
Okay.
Exactly. So is it okay if I
Yeah, for sure. You can erase it. Let me shut this off.